Hi, everyone. My name is Alex Huckstepp. I have spent the last dozen or so years in manufacturing tech. I've worked and helped build a couple 3D printing companies, a couple robotic manufacturing companies, and now I'm focused on building software to help manufacturers. And Anna from Instrumental asked me to share sort of some of my recent research and analysis and learnings around US manufacturing capabilities and capacity and where things are going. So I only have 10 minutes here, probably less now, so I'm going to move really fast. It's like 20 slides. And probably no time for questions, but I'll distribute this afterwards. I would love to chat with anyone. So I'm going to focus in on these three, I think, topics that are, these spaces that are relevant to people here. The current state of electronics manufacturing in the US, robotics, automation, and software and AI. And all these things, of course, are related to. So starting off with kind of the bad news that I think most people here are aware of. You know, it's funny being here on this old aircraft carrier with all these old aircraft around. Like it's this funny reminder, right, of this like powerhouse of manufacturing that the US used to be. Most historians actually make the argument that we won World War II based on our manufacturing capability and being able to really scale up in building all these ships and aircraft and weapon systems. And clearly, a lot has changed since then. You know, we were the factory of the world, the manufacturing powerhouse of the world for decades, even after World War II. But in the last few decades, especially, you can see we've continued to lose kind of manufacturing share as a percent of GDP, as a percent of our GDP. So when you look at all these other countries here, which are kind of the dominant advanced manufacturing companies in the world, we are the lowest. And you can see that same kind of trend here with our trade deficits, right? So other than the recent kind of exception with the US-China trade war kind of reversing this deficit a bit, we've been basically outsourcing more and more, right, to almost every other region in the world. One more view of this, which I find kind of interesting, is laid out on a map. And while we are, so in 2010, China passed us as the largest manufacturer, as a sort of total value-added manufacturing economy. We've since continued to kind of slip, but now, even though we're a very large economy, you know, we have only, I think, like, we have about 20 countries that have a higher relative percent of GDP going to manufacturing. So let's zoom in on the US and some specific manufacturing verticals. So other than food and beverages, we have been losing manufacturing companies in virtually every sector. So this is since 2020. Sorry, this is since 2002. We've lost now 45,000 companies making products across all these different industries. Almost, thousands of companies across almost all these different industries. And I think we're all here because we're interested in sort of reversing some of these trends. If we focus in on semiconductor manufacturing capacity, of course, invented here, again, we were the dominant manufacturer of chips for decades, starting back in the late 50s. And, this doesn't really come across clearly, but we have been losing a lot of we basically outsourced all our advanced semiconductor manufacturing capacity over the last few decades. And we'll talk in a second about how that's starting to come back, which is great. But the current state is not, right? We're only about 10% of the global semiconductor manufacturing capacity in the world, and we consume a lot more than that. So quick look at battery, the state of batteries. Again, China completely dominating. Other than, I think, about 10% of cell manufacturing happens here in the US. Almost every other segment of that supply chain, right? China has a complete stranglehold on this. Robotics. So things are not moving in the right direction with robotics. So last year, China actually deployed 51%, more than half of the world's robots. And Europe deployed 14%, we deployed 7%. When we look at robots as a function of 10,000 workers, we're falling further behind in terms of the density and the utilization of robotics and automation. And it's never been more needed, right? We have this massive labor gap. We have this massive especially skilled gap in labor. And a lot of you have probably seen in the news over the last month, this Boeing machinist strike. And what's astounding to me is that there's 30,000 machinists at Boeing that are on strike. We only have a few 100,000 machinists in the U.S. So this is a huge percentage of our sort of machining capability that's not even working. And this is someone said it before, right? Machining is a craft, is for sure a craft, doing complex, high-value machining. And this gap continues to grow. They're predicting there's going to be over 1 million jobs by the end of the decade unfilled in manufacturing. So we need technology to help us. So what's coming next for Made in the USA? Let's talk about the future. So I loved seeing this chart. I love starting to see this data a year or two ago. So in 2022, the US government passed the CHIPS Act and the sort of poorly named Inflation Reduction Act. And it's having a huge impact on our manufacturing of electronics. And so this is a leading indicator, right? This is spending on construction. A lot of these types of advanced manufacturing facilities take a long time to turn on. We may not see chips or batteries or whatever it may be come out of these for years, but this is really nice to see this insanely large acceleration here in new factories being built. And it's even more striking when you look at just the electronics. We basically stopped building electronics production in the US. And most of this, again, is chips. There's some battery, but most of this is driven by all these semiconductor fabs that are going up. So it doesn't come across very well. You can see all major new, I think this is all the semiconductor fabs that are being constructed in the next few years that are over $1 billion investment. So these are real factories. And quickly on semis, we've dropped down to, like I said, only about 10% of the global capacity. And while it may not sound like much, we're predicted to get back to about 14% over the next decade. So an increase of 40%. What's even more important is what I have highlighted here in red, right? All semiconductors are not the same, and the really critical cutting-edge next-gen semiconductors are these, very low, small nanometer chips. And we're predicted to go from essentially 0 to 28% of the production capacity for these cutting-edge advanced chips over the next decade, or over the next 8 years. So this is pretty exciting. And what is happening with robotics and automation? I shared before, we are way behind in terms of implementing sort of the classic industrial automation. Your 6-axis robots that are welding and assembling and moving material. But the good news here is that we are accelerating in 2 really critical areas. If you look at all these recent kind of humanoid technology products or projects, I'll call them, because many are not released yet. The US, has 4 out of these kind of 6 leading developments. And this coupled with AI, I think is going to make a huge impact in manufacturing. And they're actually predicting most of these humanoid robotic companies, they are, when they think of all the applications for these humanoid robots, manufacturing is the largest focus for them in terms of where it can drive impact. So let's talk quickly about software, and I'll wrap this up here in a minute. So many people, I think, don't fully appreciate how excellent the US is at software. If you take the 100 largest public software companies in the world, 75% of them are US. And we've dominated software for a long time. In some ways, we lost all this manufacturing capability because we kind of took our eyes off that, and a lot of the smart people were focused on software, or a lot of the people chasing money were going to software. And this, I think, is a huge opportunity. People are appreciating more and more that AI is really going to revolutionize manufacturing, the way things are designed, engineered, made, tested, inspected, as we've talked about here. And there's countless different sort of specific applications by type of manufacturing. But for us to win here, we need to really lead in AI software and AI software for manufacturing. And I think a lot of that is going to come from innovative startups, because this is a totally rethinking of the architecture of products. I recently published this kind of chart highlighting a lot of the exciting software for hardware startups, I call them, that many of these are sort of using AI at their core to drive huge advancements in manufacturing and design and engineering and supply chain. And I think that we need, of course, support these, and we need to support these companies. And these are going to be really critical to bringing kind of advanced critical manufacturing supply chains back here to the US. So that's all I have for now. Thank you so much.